Hey guys, welcome back to our channel Psychophilics. This is the part 2 of crash course on statistics for behavioral science. In this part we will be covering the topics such as central tendency, that is mean, median, mode, and then variability, range, standard deviation, quartile deviation, average deviation, and what is normal curve, kurtosis, skewness, and we will also brief about the 3 sigma rule, which is commonly used in statistics. And now let's get started. First we will talk about central tendency. So central tendency, it is the center of the distribution. It can refer to middleness of the entire set of data. It can also refer to mean, median, mode, and it is the most representative of the entire set of score. Now let's talk about mean. What is mean? Well, mean is the arithmetic average it is when we add all of them and then divide by number of scores. It is represented by mu or by capital M. We can say mean, and this can refer to sample mean. So the formula can be x bar equals sigma x by n. Sigma is the summation of all the values and n refers to total number of scores, and bar x is the mean. Now what is the advantage of mean? It is that it is the easiest of all the central tendencies, but disadvantage is that it is heavily affected by outliers. Now what are outliers? These are extreme scores. Now when we say mean, it is the middle point of the set of values. Now let's move on to our next topic, median. Now what is median? Median is the mid score after arranging high to low or low to high. It is the middle point of the list, or it is one which cares about number of cases, not values. Now this is very much important to note that it cares about the number of cases, not the values. So therefore it is not it is insensitive to extreme scores and thus not affected by outliers. Therefore it is a good question that why do we use or prefer median over mean. One reason can be it is insensitive to extreme scores, it is not affected by extreme scores, and it has a positional value. That is why we use median over mean sometimes. Now when we say median, it is the midpoint of set of cases, whereas mean was middle point of set of values. Now here what are the various steps for calculating median? First is we need to order it up to high to low or low to high, and then middlemost score for odd is our median, whereas if it is even, if the number of data points are even, then what should we do? We should take the average of middle two numbers. So, what is the advantage of using median? It has higher resistance to outliers comparing to mean, and disadvantage is data needs to be ordered. Now we will talk about our next topic, that is mode. Now what is mode? Well, it is the most general, it is the least precise of calculating the centerness of the distribution. So, it is the one, mode is the one which is most frequent in the data set. There is no formula to calculate it, but what is the step? Step is to list and tally. Simple. So, well, there can be more than one mode. So, they all can have equal value. In that case, it is called multimodal. So, now we will move on to our next topic, that is variability. So, what is variability? Well, it is the how score differ, or how it is what is the dispersion of the data. Dispersion is if the data is clustered together or spread out. It is calculated in terms of distance. It can also refer to how much the score differ from average. It is a quantitative measure and it differentiates between scores and distribution. Now we will talk about range. Now what is range? Range is the distance covered by the score from smallest to largest score. Now when should we use range? So it is used when we want to know highest and lowest score of total spread, or we can use when distribution is too small. Now to calculate range, the formula is range equals URL x max minus RRL x min, or in simple words it is highest minus lowest equals range. So we will now talk about SD or standard deviation. It is the average amount of variability in set of scores. It is the average distance from mean. It is the square root of variance. And we should note one thing, that larger the SD is means more variable the set of score. Also, larger average distance each data point from mean. Now, standard deviation is most stable, reliable one, and it is also called as root mean square deviation. Its general formula is S or SD equals under root of sigma x minus x bar upon n minus 1. Here it is square. So this is the formula, and n equals sample size, x is individual score, x bar is mean of all score, and this sigma refers to summation, that is addition of all the units. Now when we calculate SD, we will have to make a table which will be containing these as the columns. So one will be x equals x minus m, x and x square. So these will be the variables there. Now when we calculate SD, so according to our problem, there can be two types of representation. One is for grouped and the another one is for ungrouped. Now for grouped data, the SD is root sigma fx square by n. Here the columns will be making our fx, comma x equals x minus m, comma x square and fx square, and here n is the total f. Now in ungrouped data, the SD equals under root of sigma x minus m the whole square by n equals under root of sigma x square by n. So these are the two different representation of standard deviation as per the case. Okay. So here for ungrouped data, the x is the individual score, m is the mean, n is the total number of scores, and x is the deviation from mean. So, we will now talk about quartile deviation or QD. Now, before we go ahead with it, we know that outlier is an extreme value present in the data set, and an outlier reduce the utility of range. Now, what happens in QD is we take the entire data and divide it into 4 equal parts, 25% each. Now, what is median is, in simple language, is when we divide 2 equal halves, and for quartile we divide it into 4 equal halves. So, if I represent it, so it will be like, here is the lowest, here is the highest, somewhere here is the median, Q1, Q3. Now, what is the formula for QD? QD is Q3 minus Q1 upon 2. Now, we should note that 25th percentile or the first quartile and 50th percentile is the second quartile, and the 75th percentile is the third quartile. We should also note that the first quartile is also known as lower quartile, which can be represented as 25th percentile or Q1, or which is equal to 25th percentage of initial data. Now, let us now connect some dots. So, we know that we prefer median over mean, as it reduces the outlier effect or has an anti-outlier effect. Therefore, we prefer QD instead of range due to its anti-outlier effect. So, QD is the deviation in median. So, it is the median is the arrangement, whereas in SD, when we look at SD, it is the deviation in mean average. Okay, so now let's talk about steps to calculate quartile deviation or QD. Now, to calculate QD, which is the average distance of quartiles from median. To calculate the first quartile or Q1, the formula is n plus 1 upon 4 term, whereas the third quartile Q3 equals 3 times n plus 1 by 4th term, and QD will be Q3 minus Q1 by 2. Now, this will be the value. One common error we make is we forget that this value calculated here is the term, whereas this after doing this calculation is a value. This is a common mistake we do while calculating it, so we should keep a note of that. And now if suppose we get 6.75th term, and so what should we do now? So in this case we should divide it into 6th plus 0.75th times 7th term minus 6th term. So to generalize this, it will be n point k term equals nth plus point k into n plus 1th term minus nth term. We will now talk about QD for class interval. So formula for Q1 equals L plus n by 4 minus Cf upon f into I, and formula for Q3 equals L plus 3n by 4 minus Cf upon f into I. So these are the formula for QD for class interval. Here L equals lower limit of Q class, and Cf equals Cf class preceding Q class. I equals interval of Q class, and f equals frequency of Q class. Now let us move on to next topic, AD, that is average deviation. So in AD it takes into account the different fluctuations and variations. It is the mean of deviations of all separate scores from their mean. Now in AD there are two major formulas as per if the data is grouped or the data is ungrouped. Now in group data the formula will be AD equals sigma mod of fx divided by n, and the various steps or the various columns we will have to make is f, then midpoint x, and fx, and x equals capital X minus m, then f small x, and mod of f small x. Now for ungrouped data the formula will be AD equals sigma mod of small x by n. Now here these steps will be calculating capital X, small x, which will be capital X minus m, and then mod of small x. Now when we now let's talk about m. So m will be sigma of fx upon sum of frequencies, or we can say sigma f. So when we talk about average deviation, it calculates on absolute value. So it is not affected by the larger value, and it overcomes negative difference. Now when to use AD? It is to be used when data is not evenly distributed. So by now we have learned a lot about different variability techniques of such as range, standard deviation, quartile deviation, but the question is when to use and what. So if suppose we have if suppose the highest and lowest score is only required, then we should go ahead with range. Also when distribution is too small, and standard deviation should be used when we have to use something which is high in reliability. So this is most reliable, and we have to use this when we are computing correlation coefficient or the significant difference, or when central tendency is available as mean, and also when distribution is normal or near normal. Now when to use quartile deviation? When the distribution is skewed, when central tendency is known as median and distribution is irregular, and when we want the data to be concentrated around mid 50%, or when the percentile and quartile are already computed. Now to recap, we have to use range when the distribution is too small, we have to use SD when the data distribution is normal, and QD when the distribution is skewed or irregular. Here in SD, the central tendency is available as mean, whereas in QD, central tendency is available as median. So now we will talk about an important topic called normal curve. Now, what is normal probability curve or NPC? Well, it is used when we want to generalize and it is symmetrical and bell shaped. It is also called as Gaussian curve. And in normal probability curve, the mean, median and mode are equal and they are at the center. Now, when a data is normally distributed, it means it is unimodal, that is only one mode. Now, when we talk about normal curve, it is asymptotic, that is it never touch the base, that it indicates that it is tending towards negative infinite to positive infinite. Now, to graphically represent what asymptotic means is, suppose this is a graph and this is tending towards positive infinite and this is tending towards negative infinite. Here when we see this graph is not touching the base, that is they are almost parallel. And if they are parallel, they won't intersect at any point when we extend the graph towards the infinite. We will now talk about kurtosis. So, what is kurtosis? It is how flat or peaked a graph is. So, it can kurtosis can be of like three types: mesokurtic, leptokurtic and platykurtic. Now, when we talk about mesokurtic, it has medium height distribution and moderate breadth. Leptokurtic will be tall and thin, and the middle will have high frequency. Platykurtic are short and broader. To represent these graph, this graph will be somewhat like this. Leptokurtic will be like this. And platykurtic will be somewhat like this. These are representative of the graph, not the actual. So, these are the rough diagram of how a graph will look like. It will have medium height and moderate breadth. It will be tall and thin, and middle will have high frequency, as you can see here. Now, platykurtic will be short and broad. So this is all about kurtosis. Now we will talk about skewness. So what is skewness? Well, skewness is the lack of symmetry in a graph. So when we say that the graph is skewed or the distribution is skewed, it means that mean, median and mode are not same. So now if we recall from our early learnings, so if a graph is symmetrical, then there is a possibility that it is a normal probability curve, and for that the mean, median and mode will be the same. Now many people get confused that how should we find if the graph is positively skewed or negatively skewed. So there is a trick to find it. So the trick is mean, mode and mode. If the mode is found towards the right of mean, then it is negatively skewed, whereas if the mode is found towards the left of the mean, then the graph is positively skewed. Or the second trick is, if the slant curve is towards the right, then it is positively skewed. Now we have approached towards our last topic, that is 3 sigma rule, which is also called as Gaussian rule. So 3 sigma rule is that 68% of area under curve is occupied, then it is plus minus 1 SD. For 95% it is plus minus 2 SD. For 99.7% it is plus minus 3 SD. Now to graphically represent it, if suppose this is the approximate graph, suppose this is the, let's assume that it is mean and this is 1 SD, similarly 2 SD, then 3 SD. Now this area will be 34% and this area will be 13.5 and this will be 2.35 and the last one, it will be approximately 0.15%. So these will be the approximate percentages: 34%, 13.5, 2.35 and 0.15%. So this is the simple Gaussian rule, and we have reached towards the end of this part 2 of Crash Course on Statistics. Please do like, subscribe and share our videos, and if there's any comment, please feel free to drop it in the comment section so that we can improve our videos. Thank you so much.